Welcome to db4o Windows Mobile 6 Contact Synchronization sample. During this video tutorial, we will show you how easy it is to synchronize your Pocket Outlok contacts on a Windows Mobile 6 device over the air against a db4o database server. As you can see, our Visual Studio 2005 solution consists of three projects. Device Application 1, which is a Windows Mobile 6 device application which associated form you can see on the screen right now. db4o Server, which is a Windows Forms application which starts a db4o server and runs on the background. Class Library 1, which is a class library encapsulating domain classes and a data access object layer for interaction with db4o. First of all, before we jump into the code, let's take a look at the sample in action. We are starting two projects in parallel here: the device application, which runs on a Windows Mobile 6 device emulator, and the db4o server, which runs on the desktop machine. As a first step, let's start the server using the default parameters. If we click on Status, we will see that there are no contacts on the server yet. Let's generate a few sample contacts on the server. Note that they will show an Outlook contact ID of 0 and always start with the name of James Smith. Now let's also generate a few sample contacts on the device. Note that device parameters must match the ones in the server and that the IP address must be the one for your desktop computer if you're running the server locally. Now let's take a look at the device contacts. As you can see, all generated contacts on the device start with John Doe and are automatically assigned an Outlook PIM item ID. Now that we have different contacts on each side, let's do a synchronization. During the sync process, Outlook contacts are mirrored into a local db4o database on the device. This database and the remote db4o server database serve as providers to DRS, db4o synchronization technology. It couldn't be simpler. Now all contacts have been replicated between providers. We can now see the new contacts on the db4o server that have been replicated from the device and vice versa, the additional contacts on the device brought from the server. Let's take a look at the source code that performs the replication. I will show you the sync contacts method in the DAO class, which basically takes two object containers as parameters. DRS basically needs two providers as synchronization source destination. For each provider, DRS identifies which objects have changed since the last replication. Once we obtain the set of changed objects, we replicate them back to the opposite provider. As you can see, we do this in both directions, first for provider A and then for provider B. DRS uses unique universal IDs and version numbers on objects to automate the synchronization process, so we need to make sure that we enable these features when we configure the db4o database. Finally, we must commit the replication actions for the actual synchronization to take place. And that's it. No more source code related to the replication process per se. But let's take a look at a few other db4o related methods in the DAO class. How do we open a db4o database? And how about opening a remote database? Database opening methods are grouped in this region. Note that for any open method, you always have a variant that lets you pass a configuration object. A proper configuration is extremely important for proper handling of objects and replication. We use these configuration settings for the db4o databases in the example, both local and remote. Here, assume that the parameter class is the db4o contact class, which is basically the only domain class for the sample and the one that we store and query throughout this example. As a first step, we solicit a new configuration object that we will tweak according to our needs. Then we set the global activation depth to 0, which means that for all persisted objects, only primitive non-object fields will be activated by default when retrieved from the database. Now, we specify more granular configuration options applicable only to db4o contact objects. We set the update depth to 1 because we also want to update basic db4o contact members. Since db4o contacts is a flat object, we also specify a shallow activation depth of 1 as minimum, which is anyway deeper than our configured global activation depth. Finally, with cascade on delete set to true, once a delete operation is started on a db4o contact, we tell db4o to completely delete the whole object hierarchy for the object. On the second section of the configuration, we specify two indexes for the fields ID and file as, which help with speeding up queries. The last part, as we mentioned before, is absolutely necessary for the database to function as a replication source destination for DRS. Now back to the open methods, you can basically specify a file name to open a local database, or server parameters such as hostname, port, username, and password to open a remote database instance. See the method openClient. Additionally, you can start a db4o server instance again by specifying basic server parameters with the method openServer. Now we can expand the database queries region to take a look at the basic queries that we perform against the contact database. A db4o contact is a flat object, so queries are very simple. The most used query is the one to fetch a contact from the database by ID. I have provided 3 different versions of the same query for your reference. Native queries, Soda, and query by example. They all take an object container and a numeric ID as a parameter. An object container is the object that serves as interface to the db4o database, so it's our db4o database for all practical purposes. Note that in the native query, the ID field is referenced directly from a contact object. While in the Soda query is passed as text. This means that native queries are refactorable, compile time checked, and context-aware in the IDE, while references to fields and other constructs in Soda are string-based and prone to runtime errors. In query by example, it's not the ID itself that is used for comparison, but rather an empty db4o contact object with the ID field set. We call this a prototype object, which fields are explored via reflection by the query by example system to find similar objects in the database. Also note that you need to cast the objects in the query results for Soda and QBE, but you don't need to do that for native queries. We hope you've enjoyed this tutorial. You can download db4o and DRS at www.db4o.com and build your own synchronization solution in a snap. The sample with source code is also available in our project section.